Hello and welcome to the lecture on Lighthouse Project at Agartala. My name is Shailesh Agrawal, Executive Director, Building Materials and Technology Promotion Council, and I'm going to educate you all through this presentation on Lighthouse Project about the field level implementation of innovative construction system being used in this LHP, including design basis, materials, manufacturing, structural drawings, detailing, and actual site photographs explaining the different construction stages. The outline of my lecture is as follows, starting from Global Housing Technology Challenge India and Lighthouse projects, the technology in terms of various structural elements, namely foundation, structural system, floors, wall panels, will be discussed, followed by construction activities at site. Ministry of Housing and Urban Affairs organized Global Housing Technology Challenge India, uh, through which proven demonstrable technologies which can help build maximum number of houses in minimum time and minimum cost were identified, evaluated, and shortlisted for future construction. The Construction Technology India Expo was organized on 2nd and 3rd March under GHTC India, which was inaugurated by Honorable Prime Minister of India, and we could identify and shortlist 54 new construction systems, which were broadly categorized into these 6 categories. Today, I'm going to discuss light gauge steel structural system and pre-engineered structural system, which is being used in the Lighthouse projects, which is currently going on at Agartala, Tripura. Just to give you brief about the 6 lighthouse projects, these 6 lighthouse projects are being executed at present in different parts of the country, as you can see in this slide, and all the 6 broad categories are being implemented with 6 distinct technologies at all these places. More than 1,000 houses are being constructed everywhere in a structural configuration of 6-story to 14-story. Before getting into the technical details about the technology, let me just give you an overview of the project at Agartala. The total plot area given by the state government is 24,168 square meter, and out of which 31% area is kept as green. There are 7 blocks which are in G+6 configuration with 1,000 houses, along with basic and social infrastructure. If you want to have a look at the typical floor plan, each floor plan has 16 dwelling units, which are planned like this: 1, 2, 3, 4, 5, 6, 7, 8, and we are 2. So 16 dwelling units in few blocks and 24 dwelling units in other blocks. And each block has provision of lift and staircase. Let's have a look at the typical dwelling unit plan. Each dwelling unit comprises of a bedroom and a living room. Then there is a toilet plus bathroom with separate access from both the rooms to toilet and bath. There is a provision of kitchen as well, along with balcony. It is worth mentioning here that the space norms for this typical dwelling unit for EWS house conforms to the National Building Code norms. National Building Code 2016 of India specifies space norms for EWS housing. Space norm means the sizes, the minimum sizes of living room, minimum size of bedroom, the size of kitchen, the height of a room, the width of a toilet and a staircase. All these things are specified in National Building Code. In addition to compliance with National Building Code, there are other special features which have been included in the project. The project has to have a green rating as per GRIA. Then use of renewable resources have also been included in the project with the provisions of rainwater harvesting and solar lighting. Solid waste management and sewage treatment plant with recycling of water is also part and parcel of the project. Since it is G+5 structure, firefighting norms as per National Building Code are also included in the project. Now let's get into the technology. On the left hand side, what you see is prevalent construction practices which are in vogue. So on our left hand side, on the topmost, you see a load bearing structure where the load bearing walls are constructed, by brick by brick with mortar layer, and these are load bearing walls. Over these load bearing walls, a cast in situ slab is normally cast, or you can have a sloping roof. So this is a typical construction which you will find in most of Indian cities, especially tier 2 and tier 3 cities. Below that picture, you find a typical construction which is norm of the day. This is cast in situ RCC frame construction, and what you see here is these are cast in situ RCC frame over which cast in situ slab is cast, and then the walls are infilled with brick or any other blocks. So this is a typical construction which takes place in our country as well as abroad. What you see that these two construction practices are no longer sustainable because there is wastage of material. They are sometimes not disaster resilient as well. There is time overrun and cost overrun, and if I need to explain you time overrun and cost overrun, the stipulated time of completion of the project is normally exceeded. Number one. Secondly, because there is too much demand of conventional building materials, so by the time you end the project is ended, the cost gets escalated. To avoid all these things and to bring safety, sustainability, and the speed into the construction sector, these two systems are being replaced here by this system which you see on right hand side. So the frame, this RCC frame, is being replaced by steel frame structure, and these steel frames are built up sections which are made in the factory and then assembled, erected at the site, assembled through nut and bolts, and giving robust structural steel frame structural system. So as a replacement to RCC frame, we are using steel frame structure. Along with this, the infill walls, which are here of brick masonry, they are being replaced by light gauge steel frame walling system. So these are again factory made light gauge steel panel. Light gauge is also known as cold form steel. So this is a hot rolled steel, and this is called light gauge steel is a cold form steel. And these light gauge panels, from both the sides, they can be encased with the cement fiber board, and in between you can fill it with lightweight concrete or rockwood. So this becomes a wall panel which can be easily fixed in between this space to give it a structure. So the prevalent construction practices in this project are being replaced by a structural system of steel, hot rolled steel, and a walling system of light gauge steel, framed system. This LGSF, the acronym of light gauge steel frame is LGSF. It is also factory made galvanized light gauge steel components, and these components are produced by cold forming method. Unlike hot rolled steel, which is done at a high temperature, the steel is being laid. Here, these components, like LGSF components, are produced or manufactured by cold forming method and then assembled at site as panels. And these light gauge steel frame walling system can also be used as load bearing applications as well as for non-load bearing applications. In this project, it is being used as an infill wall because the structure is G+5, which is 6-story. And at present, we have recommended the buildings to be constructed with light gauge steel frame walling system up to 4-story only. Because it is a 6-story structure and Agartala falls in a high seismic zone, which is zone 5, the hybrid system comprising of steel structural frame with LGSF walling system is proposed in the project. Now, let me explain you the technology with reference to all these structural elements. If you see at the picture on the right hand side, you will see basically the structure comprises of foundation, This is your foundation, and basically this is a foundation slab over which a stem column is cast up to the plinth level, and above plinth is what we call superstructure comprising of structural system, floors, and wall panels. Structural system is skeleton of your building and comprises of these vertical members, which are called columns, and these horizontal members, which are known as beams. Once your skeleton is cast, then over that you lay the floor, which is also known as slab. So these slabs are cast over that, and once this is cast, you have to fill the spaces in between frames through infill walls, and that is called wall panels. So primarily the structural elements of a building comprises of foundation, then structural system, which is beam, column, frame, then a floor or a slab, and then these are the wall panels. In addition to this, you have sunshade, staircases, and other things as well. So I'm going to explain you each of these through the system which is being used in this project. Let's get into the foundation. Agartala, the land given to us was marshy land, and when you have a marshy land, there you can't go with the conventional typical RCC footing. So what is proposed here is pile foundation, and these pile foundations are known as bored cast in situ concrete pipes. So what is done? Boring is done at the site itself, then reinforcement cage is lowered, and then concreting is done. And these pile foundations are designed structurally as strictly following the geotechnical investigation, bearing capacity of the region, of the site, and the subsoil strata, including water table. Once these piles are laid, so you can understand that pile is like a column which goes inside and whenever you have a marshy land of soft soil, when you insert piles in the ground, you improve the ground as well. So bearing capacity gets improved, and thereby you achieve the required strength for constructing a building over the foundation. Then once pile come up to the ground level, then a raft is laid so that all the piles are connected together, and then over that RCC column and the RCC columns are being cast, and then once we reach at the plinth level, the steel columns which are made in the factory need to be erected. So if I have to tell you in brief the foundation details, we are having pile foundation, which are known as bored cast in situ concrete piles. Then over those piles, RCC raft is being laid, and on RCC raft, RCC pedestals, which is also known as stem columns, are being erected, and on those stem columns at the plinth level, you'll have to put a base plate, which along with the steel column. Okay, and wherever we have staircases and lift wells, their RCC shear wall is also being provided, because staircase and lift wells have more live load, and therefore they are being provided in addition to the usual raft. The RCC raft thickness is also increased, and also RCC shear walls are being provided as lift core wells. It is structural system. If we talk about the structural system being used here, is steel structural frame, which comprises of these built-up column sections and built-up beam section. They are I sections which are fabricated in the plant, normally typically in a steel plant, and this kind of structure is also known as pre-engineered building system. This pre-engineered building system was quite popular in industrial structure, but now in residential sector also it is being promoted, and it's becoming popular. The floor is deck slab, and why it is called deck slab? Because once you erect this steel column, over that you put a deck sheet. This is known as, it is a steel profile sheet of 0.9 mm thick. It is a galvanized steel deck sheet. So over this deck sheet you lay the reinforcement, and then you do the concreting, and that concreting is of around 75 to 100 mm over the nominal reinforcement. So here in this project, the deck slab is being used. Then let's come to the walling panel, and this is the innovative technology which is being used in this project. The walling panels are made of light gauge steel framing. So typical light gauge steel frame looks like this. So they are manufactured in the factory. They are galvanized, so there is no problem of corrosion, and these panels can be fabricated in form of an entire wall panel like this in the factory, and all you have to do is you have to erect them in between the steel columns and beams like this. Okay, and LGSF, typical section of LGSF is a jet section and C section. They are very thin, having high strength to weight ratio. And in this project, primarily we are using C section, which is made of galvanized light gauge steel, and there are built up notches, dimplings, and slots, including service holes for laying services and for connecting them with the structure, with the foundation and with the beams and steel beams and columns. And these being lightweight, they can be manually erected, assembled, and through self-driven metal screws, they can be fixed with your walls, with frames, and with the foundations. Okay, and provisions for doors, windows, ventilators, and other cutouts can be incorporated either in the factory or at the site. Once you do once you erect this light gauge panel, what you see in this slide, from on both the sides, you have to cover it, and for covering it from both the sides, in this project, we are using a calcium cement fiber board, or you can use a calcium silicate board. There are other variants available as well, but here the cement concrete panel is being fixed on both the sides. So this is a cement concrete panel, which is again made in the factory, and the hollow space in between is filled with lightweight concrete. This lightweight concrete, let me explain you, is the concrete which is without aggregate. So it is made with foam, and it's very light because there are no aggregates. So this is a lightweight concrete. So this light gauge steel frame, which is done in the factory using using galvanized cold form steel, and then both the outer face of a wall and the inner face of the wall are fixed with the cement concrete panel, and the space in between is filled with lightweight concrete. So that is the technology which we are using in this project. There are other variants also available. Instead of cement concrete panel, you can use a cement fiber board or calcium silicate board, and the in-between space can be filled with rock wool or mineral wool. A typical setup of the light gauge steel manufacturing plant is shown here, and it's a very simple plant. What you have is you have galvanized steel coils which look like this, okay, and then you loop the coils in a decoiler, something of this kind, and then these coils are passed through a computerized roll forming machine. So once you put this the coil into a decoiler, and then you pass this coil, which is very thin, through a roller forming machine to get the desired section, which can be jet section, which can be C section, or any other customized section which you require. And once these sections are being made, then you can see here, so like this, and this is how this section is coming out from this roll forming machine. And all these machines are handled through computer, and this is a machine of FrameCAD, which is one of the leading company in the world for manufacturing these light gauge steel framing thing. So once you get this section, then these sections are again depending upon your project requirements, they are given the shape of wall panels, and you can have rectangular panels, and then later either at the site or otherwise at the factory itself, these panels can be joined together through screws. Once you make these panels, then you have to properly stack them and then transport them to the site. The closure look, as you can see, this is that coil of steel I was talking about, galvanized iron, the core form steel, and this is how it is. It looks like, and this is a photograph where the panel is being extracted from that machine. So a typical light gauge steel panel will look like this, a rectangular panel, and then you can join them together. And this panel, which is shown here, is particularly used as a horizontal member, as a girder or as a beam member. And what I showed here, these are the panels which are used for walling. Now let's come to the wall frame. Having erected the steel frame as a structural system for walling, you are using this light gauge steel frame. And as I told you, the thickness is 0.7 mm thick steel sheet from which this is being made, and they are being galvanized with aluminum zinc alloy, and the coating has to, the galvanization has to be as per the international and national standard for cold forming. And there is also Indian standard available on cold form or light gauge steel, which is IS 801 1975. This code has been reformed recently, and the code is being also revised. And for steel structure or hot rolled steel, there is another dedicated code for its design and construction, which is IS 800 2007. The another advantage of light gauge steel frame is it has lightweight, so it has high strength to weight ratio, and being galvanized, there is no problem of corrosion, and the durability. They are highly durable. As you can see in this right hand side, these panels can be very easily erected over the already laid foundation or beam, and through self-tapping or self-driven screws, you can manually fix these panels with the adjoining structure or beam or column. Just to continue our wall framing the thing, if I need to tell you about the C-section. So C-section has a web depth of 89 mm by 39 mm, and there is a lip of 11 mm. So if you see this, so this web, what you see here is 89 mm is the height, and the width of this is 39 mm, and they are punched with dimples and the slot through which they can be connected. These slots are normally given in the web so that you can connect them easily. Okay, what you see here is the typical detail. What you do, you put a tracker on a already laid foundation, already laid plinth or foundation, and over that you erect your light gauge steel panel and then connect it through a nut and bolt system. So these slots are pre-made. These slots are already made in the factory, and once you erect them, all you have to do is you have to put a self-drilling tapping screw for jointing the members. And similarly, when you erect a side-by-side panel, so you can connect these two through these screws. Okay, and when you are fixing these frames or over RCC slab or tie beam, so you have to put a the rubber pad of neoprene because to avoid vibration and other things. Okay, and these frames can be supplied. The entire wall panel can be made in the factory, or they can be supplied in a knockdown condition, so that you can erect them at the site. So this is a typical detail, and this is that web I was talking about. So this is around 89 mm, and this is around 39 mm, and this small portion which you see is the lip, which is 11 mm. So this C section is quite sturdy, being and has high strength to weight ratio. Now, once you have because this is already made in the factory, and all the slots, dimples, punches, all are being done in the factory, so you have to use special screws, and those screws need to follow the specifications. So all these screws are as per international standards. So connecting frame to frame. So if you have to connect this is one frame and this is another frame. So if you have to connect required these two frames, so you have to use frame assembly screws as per the detail given in ASTM. And normally these are self-drilling type screws which are of size 10 by 25 mm. Then for erecting the wall and connecting those walls with the adjoining structural member, you have to use 8 by 25 mm hex washer head type screws, which is again based on ASTM standard. Then for fixing over this, you have to fix this precast concrete panel. So for fixing this precast concrete panel as well, you require galvanized steel screws of self-rivet type with a size of 8 by 50 mm. Then once you fix this wall panel is ready, and you have to put this wall panel with the foundation as well. So to put this in the foundation and foundation anchor bolts, the size is given here. So the point which I want to make here is that because everything is being done in the factory, so you have to follow the minimum standards and minimum specifications, and you need to put the specified issues which are normally being supplied along with these panels. Also, as you can see, these are the perforations which are put in the while manufacturing the panels, and these perforations are called service perforations, which help in laying the services, okay, whether it is electrical conduits or it is plumbing conduits. So those can be put through with these service perforations. Next, let's come to the cladding, because once you erect these panels, and as I told you, these panels, they can be, the entire wall panel can be made in the factory and then transported, or otherwise with a simple procedure by putting these self-driven screws, metal screws, you can make the entire wall panel at the site and then erect it over there. Okay, now the next part is the cladding of these LGSF panels. So here in this project, we are using 20 mm thick. So this is 20 mm thick precast concrete panel, which is being used here as cladding, or you can say these are the facing sheets which are put on the external side as well as on the internal side. And once you do these panels, then in between these two facing sheets, you have LGSF panel, and that hollow space is filled with self-compacting concrete of M20 grade. Okay, and that is done on the site. What you do is you bring the concreting mixing machine and vibration table, and then you can do this. And these panels can either be made in the factory, or they can be made at the site. In this present project, these concrete cement panels are being manufactured at the site itself. So what you require is you require a metal mold, you require a concrete mixture, and a vibration table where these panels can be made and then cured. These panels, when we design these panels, they need to be designed to withstand the load of the concrete, because when you pour the self-compacting concrete, that concrete will exert pressure on these panels. So because these panels are thin, only 20 mm thick, so these panels should be able to take or withstand the load of the concrete without failure and buckling. Another distinct feature of these panels are these panels have one rough side and other side is a smooth surface. So one side is smooth and one side is rough. These panels are fixed on either side of LGSF panel with studs and tracks using mechanical fasteners. While fixing, the rough side of the panel is facing inside, so naturally you will keep the smooth surface, smooth facing side, smooth side facing outside. So internally, when you are doing, so outside will be this the smooth side, and externally when you are doing, this will be the smooth side will be the outside. Okay, and the lightweight concrete which is being pumped into this gap between two PSP, because being the rough surface inside, the concrete will bond very well with the panels which are being put. The idea is to create a joint which is leakage free, and the joint which is monolithic. So these concrete panels, along with light gauge wall panel, along with steel beam and column should be joined together tightly so that there is no ingress of water and there are no leakages afterwards. So the entire structure should act monolithic steel concrete structure. This already I explained you. So this is how the concrete is being poured. So from the top, you pour this self-compacting concrete. And as I told you, this is lightweight concrete, which is of 1500 to 1800 kg per meter cube, as against the density of a plain concrete, which is 2400 kg per meter cube. And what is done here? Here they are also mixing EPS beads, or you can do it through foam as per the design. And the required grade of concrete used is M10 to M10. Okay, so this was about the wall. And if I tell you through a drawing, there are a lot of connections here. So all these connections need to be carefully detailed beforehand, and they are to be put in form of a structural drawing. So this is a typical drawing which shows you structural connections of LGSF panel. How do we connect this LGSF panel with the horizontal beam members? So this is how it is being connected, and as you can see, you have to put plates, and then through nut and bolt you can put. Similarly, wherever you have a this is the bracket, so this is how the bracket is being put. Similarly, you can have how to put LGSF panel with the anchor bolts, which is shown here. So all these details need to be decided beforehand, need to be designed and then put in form of drawings. And these shop drawings are given to the site engineer as well, so that the work is executed as per strictly following the structural drawings. Also, once you make these drawings are given to the factory also, where these panels are being manufactured, or where these built-up sections are being manufactured, so that suitable holes and perforations can be made in the factory itself. So all you have to do is you have to bring these panels, LGSF panels and steel panels, and then start connecting them sequentially. There are a whole lot of advantages of these light gauge steel structural frame, because they are very light in weight. Being light in weight, there is significant reduction in loads, and also they are excellent as far as seismic resistance is concerned, because lighter structures perform better in the event of an earthquake. LGSF panels are being fully galvanized. The plant of manufacturing LGSF panel is it's a small plant, and the entire thing can be done under controlled condition with computerized tools. It's very fast to erect a building using the light gauge steel frame, because once you get the panels manufactured in the factory, you have to just transport and just start erecting them. It can be erected manually with ease with the help of one or two persons. Also, these panels, it has been found, when you are using factory-made components, sometimes it's very difficult to take them to the far-flung areas, or in areas where you have congested roads or narrow roads. Okay, so but this is not the case with light gauge steel framing system, because they can easily be transported to hilly areas or far-flung areas. Also, another advantage is they are ready to move kind of structure. You can move these structures from one place to other, so which becomes very handy when you are putting intermediate shelters in areas where disaster has taken place. So for rehabilitation of disaster struck areas and to provide immediate shelters, this can be used. Also, steel being recyclable, it's a green, it offers a green sustainable option of technology, because steel and this light gauge also is recyclable, and it can be recycled a number of times. Also, in India, this light gauge and this particular combination, which I just explained to you, have been used during this pandemic time to construct hospitals and isolation wards. Let me also tell you what are the essential requirements because it's a special innovative technology. So you need to train the workforce, the artisans and laborers need to be need to be trained about the technology, about erection, about assembly. So you require especially trained, skilled workforce for this. Also, for all these technologies which we are talking about, you need to plan your services, whether it is MEP or it is or any other service that need to be pre-planned, because alteration at the later stage becomes difficult, and if at all you want to do alteration at the later stage, it may endanger the structural integrity of your entire system. So that if you feel so, that is the drawback, that you have to pre-plan everything, and at later stage it is difficult to uh, change or alter that service. Okay, door and window positions also are pre-decided, and erection, as I told you, it's a sequential process. So erection, all the panels are to be numbered, the right from the planning stage, then to the design stage, then to the structural drawing. All these drawings and all need to be shared with the manufacturing plant, and then while transporting they have to come in sequence, and then when we are doing the erection and assembly, that is to be done sequentially. So it has to be done under supervision of trained staff. But technology being simple, even the existing manpower can be trained to assemble these panels and erect this structure at the site with ease. As regards finishing items, one need to take, because we are putting the fiber cement panel, and then these are light gauge steel frames, so you have to take proper care for fixing tiles, and for other electrical fittings like putting an AC or putting a water closet. You need to take proper care. The project is is being executed on design and build basis, where the implementing agency, which is Ministry of Housing and Urban Affairs in this case, provides the detailed specification for the project, and based on that, the agency need to give the design, and that design need to be vetted by a third party, which is in this case IIT, and once the design is approved, then the structural drawings are shared with the site people, and then construction starts. For this project, the technology provider and construction agency both are same, and which is Mitsubishi Housing Private Limited. For doing the design, you need to prepare a design basis report. Earlier, the approvals were given based on the drawings, but after Bhuj earthquake of 2001, a design basis report was made part and parcel of any structural design. So first and foremost thing is to prepare design basis report and get its approval. So design basis report gives you in detail the loads for which building is to be analyzed and designed. You have to give the design philosophy, which says that the kind of structure you are assuming for design analysis. You have to give in detail the codal provisions which you are using, and it has to strictly follow national and international standards. Then you have to carefully calculate wind load and earthquake load. For this, Agartala being in the highest seismic zone, the earthquake loads need to be carefully calculated and then applied to the structure. So if I have to tell you about the design basis, the structure, substructure, which is the foundation below ground level, it is a pile foundation, and which is RCC, and then we have a raft, and over raft RCC columns are being erected, and at the plinth we are putting the steel columns. So substructure is RCC, so the relevant standard is IS 456/2000, and then superstructure is hot rolled steel built up sections, okay, and for which the code is IS 800/2007. And wherever there are lift and staircases, there again RCC, RCC shear walls are being used. So design is done for RCC piles, then RCC raft foundation, then steel structure, including RCC shear walls. The design load for foundation was 70 metric ton, and the little safe design load was 2.2 metric tons. So for this, the piles are designed, and the code for pile foundation design in IS 2911, and whereas the raft foundations are being designed for using the code 2950. This area, Agartala, being in a very high damage risk zone as far as wind speed is concerned, and on the right hand side, what you see is the wind hazard map of India, which is based on the National Building Code of India 2016, and the same map is given in IS 875 Part 3. And this is here. If you see this, this is dark blue, and this. The basic wind speed is 55 meter per second, which is highest for Indian conditions. So 55 meter per second is the wind speed, and then depending upon the size of your building, depending upon the topography, importance, and the other factors, design wind speed is calculated using the formula which is given in code, which is basic wind speed multiplied by these modifiers to get the design wind speed. That design wind speed is then converted through an empirical formula, again given in IS 875 Part 3, which gives wind pressure as 0.6 times design wind speed square. And once you know the wind pressure, that wind pressure can be converted easily by multiplying it with the exposed surface area to get the design wind load. So that's how wind load is calculated, and that wind load is applied at each story, and structural analysis is carried out, and then structural design is done. Agartala, again, being in highest wind zone, as well as it is also being in the highest seismic zone. As you can see on the right hand side, this is the earthquake hazard map taken from Vulnerability Atlas of India of the Building Materials and Technology Promotion Council, and the same map is given in IS 1893 Part 1. And this is the most important code. Please remember this code for your future endeavors. IS 1893 need to be referred time and again. Whether you are doing a work in Zone 2 or in Zone 5, you need to refer 1893 for load calculations and for other features. Okay, so this is the map, and as you can see, the entire northeastern portion falls in Zone 5, and Zone 5 being the highest seismic zone, the zone factor Z is around 0.36 for this. Okay, so based on the seismic zone, you need to refer 1893, and 1893 gives you the horizontal design seismic coefficient, which is Z by 2, SA by G, I by R, where I is the importance factor, and the importance factor taken here is 1.2, whereas R is the response reduction factor. It depends on the kind of structural frame design you are doing. So for this, the building is being designed as ductile RC structural walls and few spatial moment resting frames. So there is a table given in IS 1893 which stipulates if you are designing as RCC structural walls and spatial moment resting frames, few structural moment resting frame, then the response reduction factor will be 5. So this factors, when multiplied by design acceleration coefficient, again depending upon the height of your building and size of your building, you need to estimate the time period of your building, and depending upon the time period and depending upon the soil type, you will get this value from the code SA by G. And all these values, when multiplied together, will give you design horizontal seismic coefficient. And this design horizontal seismic coefficient, when multiplied with the vertical or seismic weight of the building or the vertical load of the building, will give you the design base shear, or that is the basic shear for which your building need to be designed. And that basic shear is a lateral horizontal load. Okay, and that lateral horizontal load, depending upon the stiffness, is distributed through a formula given in again Indian standard 1893 at each story, and the entire building is then subjected to structural analysis and then designed as per relevant Indian standard. You can carry out dynamic analysis or static analysis. Again, it is given in code. If your building is regular or irregular, symmetrical or unsymmetrical, depending upon that, you can carry out linear, non-linear, static or dynamic analysis. You can create a 2D or 3D model as well for structural analysis purposes. Also, you need to fix up the boundary conditions when you do the analysis. So steel columns are, because they are connected through the base plates, so they are assumed as fixed for movement frames and pinned for ordinary frames at top of RCC pedestal and at the support of the substructure, which is the base plate. And column beam frames are assumed as rigid jointed frames so as to have monolithic connection, and so that they can cater for lateral loads in addition to and few cases they are also treated as pin joint frames. As far as slab is concerned, because the slab is a tack slab with the reinforced steel of 75 to 100 mm. So, the clause of the rigid diagram action, as far as the slabs are concerned, rigid diagram action in horizontal direction at all floor level is assumed, which is as per clause given in 1893. So based on these design basis report, you can analyze your building, and once building is analyzed, the design can be done as per relevant Indian standard. And the most important Indian standard for structural design of RCC structure is IS 456-2000, and for steel structure IS 800-2007. And for light gauge steel framing structure, it is IS 801. I will just give you the list of the relevant Indian standards, and you can see we have the pretty good Indian standards covering all the aspects of technology construction. So for load calculation, the most important code is IS 875. It comes in 5 parts, and and it covers earthquake load, it covers snow, it covers, sorry, not earthquake load, it covers wind load as well as snow load. For earthquake load, we have a different code, which is 1893. So this list, you should write it down, or you should keep a copy of all these codes with you, and you need to refer these codes whenever you design, analyze structure or a building or do a project. And nowadays, these codes can easily be downloaded from the website of BIS, and the HTTP is manakonline.com. So by going to manakonline.com and creating your user ID, you can download most of these codes, which was not earlier available. So I strongly recommend that as a professional, as engineers and architects, and as technograhi, you must have a copy of these Indian standards. So these are the standards on loads, and as I told you, 875 covers all loads except earthquake load. And for earthquake load, we have 1893. Again, 1893 comes in different parts. For general provisions, this is part 1. Then for liquid retaining structure, there is another part. For dam and embankments, there is another part. For tall chimneys kind of structure, there is another part. Then we have the number of codes for structural steel. As you can see here, the most important code for structural steel is IS 800 2007, which was reaffirmed in 2017. Then for IS 80, then we have for light gauge or cold form steel, we have a code IS 801. So these two codes are very important. And for other steel built up sections and other, for tubular sections, we also have codes available. For composite construction as well, there is 1384 is the code. For bolts also, there is Indian standard available. For RCC, the most important code is IS 456, and I always call this code as a Bible for civil engineers. So IS 456 is must-have code, which gives you in detail about the concrete, about the structural design of various structural elements and other things. Also, whenever you are doing, you are working in an earthquake-prone area and you are working with reinforced concrete, you need to refer this code, which is very important, which is 13920. And that code provides ductility to your reinforced concrete structure. So how to design your structure as a ductile structure. For that, you need to refer this 13920. And ductility, when you're working in an earthquake-prone area, is very important, because ductility allows your failure to be delayed. What I mean to say here is that ductility means that your structure will not fail all of a sudden. The failure will not be sudden, and through ductile behavior, you can avoid the sudden collapse of your building, and which is the design philosophy if we talk about earthquake resistant design. Also, for general provisions, there is another standard 4326. So if you are doing a general, if you want to know about the general provisions of earthquake design and construction, you need to refer 4326. Then for foundation, depending upon the kind of foundation, type of foundation, for each type, we have Indian standard available. So here we are using a pile foundation. So 2911 is the code for pile foundation. Then for raft, we have 2950 is the Indian standard for raft foundation. And for other foundation comes in the category of shallow foundation. Pile is a deep foundation, and isolated footings are normally categorized as shallow foundations. So for shallow foundations, wherever you have combined footing or isolated footing, there is an Indian standard available, which is 1080. Having done the load calculations and having decided the design basis report, you have to create the model, computer model of your structure. And this is what is shown here on right hand side is the computer generated 3D model of the building, which I just explained you. So, okay, you can see here, this is the structure. These are the RCC shear walls, lift and staircase wells, and this is the 3D model. Now, this 3D model will be analyzed for so many load combinations, and again these load combinations are given in code. And if you see, there are two conditions given. Then whenever you are applying a load, one load, lateral load will act only in one direction at a time. The lateral earthquake load can come in X direction, Y direction, Z direction, but while analyzing, you have to apply it only in one direction. And similarly for wind load. Also, there is a condition that earthquake load and wind load will not act together. They will act separately. They need to be analyzed separately. So if you look at these load combinations, for earthquake load, you will get 13 load combination, and similarly for wind load. So for these 13 plus 13 load combination, you have to analyze your building, and then you have to carry out the structural design as per relevant Indian standard, again for the worst possible load combination. So it cannot be done with manually. So you need to resort to computers, and thanks to advancement in the engineering knowledge and computer aided design, we have a number of softwares available, and a few of them are written here: StatPro, ETAP, SAF, SAFE, SAP, Abacus. These are the softwares where you can you can create the model of your building. This is a 3D model. You can create a 2D model as well. Okay, and once you connect this model, it will be analyzed based on your design basis report for so many load combinations, and then for each structural element, you will get the bending moment, shear force, and bending moment, shear force, and axial force, for which that structural element needs to be designed as per IS 456 if you are doing RCC design, or IS 800 if you are doing a steel design. Okay, and as I told you earlier as well, you can carry out static analysis or dynamic analysis. You can carry out linear analysis or non-linear analysis using these softwares, and these softwares are now made compatible with Indian standards. So what you have to do is, once you create the model, you will, for the worst load the combination, you will get the structural design automatically done. So that structural design can be used. Here I would also like to tell you that the structural design means what would be the dimensions of your structural elements. If it is RC, then what would be the reinforcement, and then what should be the jointing details if you are doing a steel. So what should be in steel, you have a suppose you have a I section, so what should be its modulus, what should be its moment of inertia, what should be its area. All these things can be checked from structural design by carrying out the structural design. Also, there is another very important software, which is AutoCAD, and we all must have knowledge of that AutoCAD, because that AutoCAD is being used for drafting purposes or for creating structural drawings. Earlier, these drawings were done manually by draftsmen, but nowadays, little knowledge of AutoCAD is also must for engineers. Also, whenever you do structure analysis and design, you need to cater for these two limited states. One is limited state of collapse, and one is limited state of serviceability. So the design philosophy is the building should never collapse in its lifetime. So that is called limited state of collapse. So the building need to be designed to avoid collapse of the structure. One. Second, limited state of serviceability means the structure should remain serviceable for for during its life. Okay. So for these two limited states, the entire structural design is being carried out. So with this design basis, we do carry out the design, and once the structural drawings are made based on the structural design, those drawings are approved by third party, and then those drawings are given to the factories for fabrication of steel columns and beams, and also shared with the agency so that they can start the work at the site. So now through pictures of the site, I will show you the construction sequence, and that construction sequence is again divided into these four parts. Substructure is below the foundation. Here we are using pile, so we'll try to show you the structural lines of pile, and then we will show you the superstructure, which comprises of structural system, floor, wall patterns. Okay. So this is a typical drawing of the foundation, and as I told you, this is a marshy land, and here we are putting as many as 1700 piles. Okay, so all these piles, if you see, this is a structural drawing of piles. So these piles are 30 meter. The depth of pile is 30 meter, and if you look at its diameter is 600 mm. So 30 meter long pile is to be driven below the ground, and the dia is a circular pile. So the dia of the pile is 600 or 60 centimeter, just 2 feet. So such a big pile is to be cast below the ground, so as to improve the ground bearing capacity. Okay, and this is the detail, and then this is the reinforcement, and as you can see, there are 6 20 mm bar and 6 16 mm bars are being put as a reinforcement, and then you have to put helical rings, which are known as stirrups, at a spacing of 150 center to center. So once you know the reinforcement details, and once you know the size based on your structural and design, and once you know the location, these locations need to be carefully translated in the field, by proper benchmarking and by proper surveying. And at each location, you have to then, get the reinforcement cage made. You have to insert that reinforcement cage and then do the concreting. Okay, and what you see here, this portion is, having a lift as well as the staircase well. So here RCC walls are provided, and all other places you have what you have is pile, and over that you have this raft kind of thing. I will show you again. Okay, so this also shows you the position of raft. This is a typical setup. So what you see, this section is drawn at the lift well level. So what you see, these are the piles. So once these piles come at the ground level, then you have to do some excavation, and then you have to put this raft. So this is a raft. Idea of providing raft is to connect all the piles together. And whenever you construct any structure, or whenever you design any building, the entire building should act in a box-like fashion. And Agartala being in the highest seismic zone, you have to have a monolithic structure. Monolithic structure means in the event of earthquake, the entire structure should act monolithically, or should get shaken together. So once it acts like a box, all the elements will act together, and which is the good practice, and which is one of the the philosophy of earthquake design, that all the structures should act in sync in case of horizontal shaking. So right from the foundation level, you connect all the piles. So in case of ground shaking, all the piles will act together to counter that earthquake load. So all these piles connected through a raft, and over that raft, you can put here, because it's a lift well, so you are putting a RCC wall. Otherwise you will have column here, and then over that column you will erect the steel column. Okay, so this is a typical section, just to make you understand piles. Then you have a raft, and this raft is 500 and wherever we have a staircase or lift wall, the thickness is increased to 800 increased by 300 to 400 and over that, if you have a lift wall, you put shear wall, and at other places where you have rooms and all, there you put a column. Okay. So this is again a slide, as I told you, that RCC raft is cast on piles, and then concrete pedestal are cast over RCC raft. And this typical structural layout shows you the detailed drawings, which shows the drawings of your the concrete pedestal. So this is the kind of concrete pedestal you have. So you have, and this, what you see, these rectangular portion, this is that concrete pedestal. It is also, you can call it stem column, or you can call it column only. And what you see here is that RCC shear wall. So this slide, this structural drawing, shows you the layout of pedestal along with the locations of the shear walls. And if you want to know the reinforcement of these pedestals, that reinforcement is carefully given here along with the stirrup details. Also, let me tell you here that this is called stirrup. This detailing of stirrup is also very important when you are constructing a structure in zone 5, because these stirrups held your vertical reinforcement together. So tying of this reinforcement has to be as per 13920. So detail of these stirrups and reinforcement gauge, all these things can be read from this structural drawings. This is another section. The last section which I showed you was a section cut through lift and staircase well, and this is the section at other place. What you see here, you have a pile here, and above that pile you have this raft of 500 thick, and over that raft you put this pedestal or RCC column. And that RCC column gets terminated at the plinth level, where you already put the anchor bolts, and these anchor bolts are already cast through with these columns. And then all you have to do is you have to get the column, fabricated I section column, hot rolled steel section column from the factory, and erect over that column comes with base plate. And all you have to do is you have to just erect that column and connect it through nut and bolt. Okay, so once this pile thing is done, and when this raft is being made, it can be done very fast. If the columns are ready, you have to just erect, align, and fix them through anchor bolts. So I hope it is clear. First you do the piling, then you put this raft. Over that raft you put the pedestal, and come to the finished floor level or the plinth level, and at that plinth level through these anchor bolts you connect the steel column. Okay, so this base plate is also very important, which will also be shown to you along with this anchor bolt, because the overturning or the structural performance of your entire superstructure depends on this anchor bolts, design of these anchor bolts, die of these anchor bolts, and how deep they have been inserted into the column will help will help prevent the overturning of these. So they need to be carefully designed as per the requirements. So this is how it is shown. Again, a picture from the site that once you do, this is a template, because the template of a base plate, because you can't make an error. So there is a zero tolerance for putting these anchor bolts. So normally anchor bolts are put along with this template, and so this template and these anchor bolts through sleeves, they are inserted into the column, and then they are cast and then left like this, and then over this a column will come with base plate, and then through nut bolt it will be connected. So this slide shows you fixing of anchor bolt with templates over which factory made columns with base plate will be erected. Okay. Okay, and this is the plan of that base plate, because as I told you, base plate is going to play a very critical role here, base plate and anchor bolts, because that is the only medium, or that is the only structural element which is transferring the load of your entire building to the foundation. So this is a layout of anchor bolts and base plate, how these base plates are to be put in which direction. Suppose this is like this base plate is like this, and the position of these anchor bolts is also shown here. And remember, I showed you this is the dimension of anchor bolt, and depending upon the dia, what should be this length, which is inserted into the column pedestal, or into the stem column, and what should be left above that column is given in this. So depending upon dia that is given, then it has to be 190-degree bend, and what should be the length of this bend is also given in this table, and this is as per design. So all these things need to be carefully done, referring to this structural drawings time and again, and then need to be checked by the third party as well. This slide shows you again a typical detail of how to fix the superstructure with the already laid foundation. So this is the detail of closure look on the anchor bolt, and this is that anchor bolt. If you see the detail, this is the anchor bolt, and this anchor bolt has to be bent at 90-degree, so as to have the proper grip and have sufficient lap, so as to avoid failure. So depending upon the dia, if it is a 16 mm dia bolt, then the portion which is to be inserted in the concrete is around 400 mm. Then it has to be bent at 90-degree, and this length should be 100 mm. And above the base plate, it should be above the base plate, it should be 100 mm. So based on that, you have to first cast this, and then you have to erect the column over. Okay, so this shows typical anchor detail, and this is the typical base plate detail. And if you cut a section of the base plate, you will find in a plan like this. So you have to put 4 anchor bolts, and this is the size of the size of the pedestal, and that pedestal the size of the base plate, which is put over the pedestal. So this is pedestal which is shown here, and this is the base plate. And the dimension, there should be a clear what it is called, this is a clear what we get clear offset, which is to be left, is a minimum 50 mm. And what is the significance of this? That minimum 50 mm clear offset, because otherwise this may fail in punching. So similarly for anchor bolts, there should be, this is called edge distance. This edge distance is again specified in code, because if you don't provide that much edge distance, this may fail in punching. And similarly, this base plate is of steel, and this is of concrete. If we don't provide this sufficient offset or edge distance, this may fail in punching. Okay, so that also need to be carefully seen and carefully implemented at the site. Once concrete pedestals are cast, then you connect those pedestals using plinth beam. Okay, so once you have come to the finished floor level, all the concrete pedestals, which we can call RCC columns, they are connected at the plinth again by the plinth. So it's a very robust foundation system we have proposed here, because what you are doing here, you have a 30 meter deep pile, which is the 600 mm with a 600 mm dia, 2 foot dia pile of 30 meter length. It's quite huge, so you need to ensure proper structural integrity, or monolithic. You have to ensure monolithic action even for all the piles. So all these piles need to be connected at proper level. So what we have done in the design, we have connected these piles at the ground level using a raft, and that over a raft up to the plinth, we have put RCC pedestals, and those pedestals are again tied together through plinth beam. And idea is to create structural integrity and monolithic action, being in highest seismic zone. Unfortunately, in this project, there is not much to show because right now the work on piling is going on. There is the piling work itself is huge because there are around 1750 piles which need to go 30 meters below natural ground, and the diameter of each pile is 600 mm. So right now the work on pile is going on, and also the weather there is not favoring the contractor. So at present, there is not much to show, but this slide shows you, and when you are doing such a huge piling and such a deep and a big pile, you have to do it with some mechanical equipment. So this is how the boring of pile takes place. So this is a hydraulic rig, and through this rig, and you can see this is called aguar. So this aguar is through this hydraulic rig, this aguar is inserted in the ground to create a bore, and once that bore is created, you will put a reinforcement cage. Okay, so once that bore is done, then these reinforcement cage, again, they need to be carefully. Reinforcement detailing is the most important thing when you are working in seismic zone 5. These reinforcement cage, these are called reinforcement cage, are being made side by side, and at the same time you are doing this bore through this hydraulic rig, and which is connected with this aguar. So this aguar helps in creating a hole in the ground. Once you make this reinforcement cage, then this reinforcement cage is inserted, and then concrete is being done. Also, let me tell you, what you see, a circular kind of thing, these are called helical reinforcement, or it is also known as shear reinforcement, or it is also known as stirrup. This is the most important reinforcement in addition to this vertical reinforcement when you are doing a project in earthquake prone areas, because stirrup is very important. So the dia of stirrup, the diameter of stirrup, and the spacing between two stirrups is very important, because these stirrups will hold these vertical bars together. So if they are not properly spaced, if they are not of particular dia, the entire exercise will go waste. So this has to be properly detailed and then executed and decided. So here, these are steel cages with helical reinforcement, and these are being inserted in the already bored pipe holes. And then once you make the pile holes, then you have to flush out the borehole with bentonite slurry, and bentonite slurry will help you in plugging the leakages of water and all, because you are going so deep, so you may encounter water. So normally a bentonite slurry is poured, and then once you do the bentonite slurry, you can pour the concrete, and the grade of the concrete is also very important. Here, higher grade of concrete is being used, because higher you go for the grade of the concrete, the performance becomes better, and it becomes impermeable. So for below ground application, normally a higher grade of concrete is being used. Okay, so this is how the concrete is being poured, and these are the two pictures. So this is again ready mix concrete, and which is being poured here like this. Okay, so that way first all the piles will be completed, and then over that raft will be cast. As I told you, that material specifications, because when you are doing RCC work, the grade of concrete and the steel reinforcement detailing is the most important thing for earthquake prone areas. So for piles, raft, and shear walls, because basically we are using RCC, M30 concrete grade is proposed by the designer, and for plinth beam, because it is just above the ground, so for plinth beam and grade slab, M25 grade concrete is being proposed. And it is again recommended that you need to carry out the mixed design and reinforcement. All reinforcement need to comply with this IS 1786, because reinforcement is also very important, and the elongation, the composition of reinforcement need to comply with this 1786, and all the bars being used are having yield strength of 500 Newton per mm square. So the steel bars which you use, they come with this nomenclature. This is Fe250, Fe500, Fe600. So Fe500 is the TMT bar or a reinforcement bar having yield strength 500 Newton per mm square. The IIT Delhi did the concrete mix design for this project, and concrete mix design is very essential when you are doing the mass concreting and when you are using concrete at such a scale, because this will help you conserve, materials. You can optimize the use of these precious materials, cement, aggregates, and you can achieve the desired compressive strength by optimizing the use of materials. So as you can see here, as against M 30, because of good mix design, you are getting a strength of 40. Okay, and similarly for my M 25, you are getting the target strength is 25, and you are achieving the compressive strength of 34 Newton per mm square. Okay, so normally for it is a good practice to carry out the concrete mix design and have a batching plant at the site. So this is a batching plant which is being put by the agency, and batching plant normally optimize your resources as well as building materials. So to bring resource efficiency and optimizing use of different building materials, cement and aggregates, and for better quality control, you always it is recommended to have a batching plant. The batching plant will help you also to put all the materials in the right proportions. So it's like making a food. If you want to have a tasty food, you have to put all your ingredients in the right proportion. Similarly for concrete, if you don't put the ingredients in right proportions, you will not get the desired output in terms of compressive strength, slump, and other things. So it is very important when you do a project of such kind that you carefully put the ingredients in right proportions. That is one thing. Secondly, you can do everything on papers, but how to get them executed at the site is another story. So batching plant, computerized batching plant will help you assure what you have done on papers. Also, all the sites must have a quality control and quality assurance lab. And this slide shows you a compressive testing machine, because whenever you do a concreting, you need to cast cubes, and those cubes are used to ascertain the quality of concrete, okay, in terms of compressive strength. So you make those cubes, and then through this compressive testing machine, which are nowadays computerized, you will put the cube here and try and find out the compressive strength. So if that compressive strength is below the target strength, then that means the concrete has failed, and you have to do the concreting again. So the strength of the cube need to be more than your target strength. And that is why the quality labs are being established at the site. Also, apart from establishing quality control labs at the site, the third party inspection and monitoring is also being done in these projects. And in this case, IIT Madras is the third party inspection and monitoring agency. They also come to the site and assure the quality by checking the reinforcement details, by taking samples of reinforcement and concrete cubes, and testing at their own level through the other parties. Okay, now let me come to the structural system, and there is not much to show because right now the piling work is going on. So whenever we reach to the structural the superstructure connection level, we will share those slides with you and explain you those things. But just to give you the idea that this is the structural system which we are using. These are factory made built up IE steel sections which are being manufactured in a steel plant, and once they are ready, they will come with all the holes and all, so that you can simply assemble them at site by putting nut and bolts and through gusset plates and all. For the time being, I will show you through sketches and drawings all these structural system, and later when we do it on site, we will share that presentation as well with you. Very important, in order to transfer the load to the foundation. Let me tell you here that the purpose of a building is to transfer the loads to the foundation or to the soil or to the soil strata safely through your building. So the load which is coming on building or the purpose for which building is intended to. So for that purpose, the entire load which is coming on building, whether it is a wind load or live load or an earthquake load, that need to be transferred to the ground safely through your building. And the structural system helps transferring that load through foundation to the soil. So you need to have a clear-cut load path through which the load should be transferred, and it has to be, structural integrity need to be ensured. If there is a cut in a building, so what will happen? Your load will not get transferred. So you need to have an integral action, so there is a smooth transfer. Or if I tell you in earthquake parlance, your structure should have a clear-cut load path for transferring the load of the structure to the foundation. So therefore, you need to design, detail all the connections carefully, and implement them at the site carefully under proper supervision. So this slide shows you connections. How to connect column to column is shown here. When you are putting a column over others, so on a length, the column is to be connected through nut and bolts in the web and flange portion. So here you can see here, this is the web portion, this is the flange, and through a plate you can connect these two columns. So this is how it is to be put, and minimum number of anchor bolts and all these things are to be designed as well. Similarly, if you want to connect a shear wall with the steel beam, this is how it is to be done, because at few places we have lift and staircase well. So how they are to be put, because you are using concrete on one hand and you are using a steel on another hand. So both these things cannot be joined as it is, because one is concrete and one is steel. So what you have to do is, while doing the casting, you have to insert a plate, steel plate, which is called the base plate. It's a steel plate or base plate which is inserted here through lug bars, and then through nut and bolts and teeth angles you connect your web and flange of your beam with this steel plate. So that's how steel beam is connected with your RCC wall, and this is the section which you can see. So it is connected at the web level here with bolted connections, and what you put is a plate here, a steel plate, which is connected through lug bars, and then it is connected through nut and bolt. Okay. Similarly, each joint will transfer the load to the, you have a slab. From slab, load will go to the beams, and beam will transfer this load through beam column connections to the column. So beam column connections are very important for structural integrity and for for having desired objectives or desired performance. So again, the beam column joints are designed in two categories. One is beam, one is shear and moment connection, and one is shear connection. So wherever we have shear connections, primarily shear connections are used for transferring only the shear force, and beam and moment shear connections are being used to transfer shear as well as moment connections. So wherever you have shear connections, this is how it is being done. So again, through a base plate and cleat angle, you connect the flange of your beam and column through nut and bolt. So this is how this connection look like. And if you cut a section, it is shown here like this. So there are 6 nut and bolts which are being put here, and this is the plate which is inserted. So flange of beam and column are connected together to create a shear connection. And if you are doing a moment connection, then you have to connect it at both the in both the portion, means the web and flange of beam and column are to be connected. And let me tell you, this is the flange. This is both the sections of beam and column are I sections. So this is the flange of a beam, and this is the and this vertical thing is the web of the beam. So this is web and this is flange of the beam. So here, as you can see, and this is your column. So column web is connected with the web of the beam. Okay, so this is the web. So that is to create shear connection. And here, as you see here, even at the flange and even at the web, both the places this is being connected. So as you see here, so this is your web portion and this is your flange portion. So that is how beam and shear columns are to be connected. And the performance of any steel structure will depend on how effective your connections are. So all these connections are designed based on your structural analysis and following strictly the Indian standard. Also, there are a number of codes available which gives you the kind of boards you have to use, what is the strength of these boards in terms of yield strength. All these things need to be seen, and those specifications need to be followed. So I will just show you that these are the different codes which are to be used when we talk about structural steel material specification. As you can see, for fabrication and erection or built-up section, you use IS 800 and IS 7205 for when you are doing the fabrication in the factory. So what are the tolerances? Those tolerances, and even at the time of erection, what is the tolerance which is allowed is also given in the code, and one needs to refer these codes. All these steel material, what is the testing, surface condition, what kind of protective treatment is to be used depending upon the environment in which you are working. All these things are also given in the code, and you need to refer the applicable code. Like the code is IS 800 and IS 2062 to know to ascertain the quality and surface condition. Now for plates, apart from steel sections, you are also using base plates. You are using a nut and bolt. So for plates, steel plates, and for connection plates, again there is a dedicated standard, and yield strength is also specified. See, when you are doing a connection with the steel beam and column, so the yield strength of all three should be in such a manner that it should not fail. If joint fails before your, if your joint strength is less than your beam, then the joint will fail immediately. So the yield strength of all the structural members along with joint need to be pre-decided, so that what kind of failure we expect is incorporated in the design. Okay, so all these plates need to be of particular yield strength, and that is again given in code, and their specifications are also drawn in these codes. Okay, so all connection plates, base plates, it's not that you just take a plate from the market. It has to have a specific specification in terms of yield strength and in terms of the composition. Same is the case with anchor bolt, and as I've been telling you, when you're connecting a superstructure which is of steel with the RCC foundation, everything depends on your base plate and your anchor or holding down board. So these bolts and anchors and number of anchors, their dia need to be designed through structural analysis, and then they need to be provided of a specific strength and of specific specification. So like here, the anchor bolts being used are the grade 4.6 having yield strength 250 MPa. Similarly, high strength bolts which we are being used conforms to IS 1367. Also, when we are doing jointing, at a few places you may require welding. So that's for welding, what kind of welding need to be done, then what is the specification of electrode you're going to use. Those things are also given in codes, and there are relevant standard. When you are erecting a column, when you are erecting a superstructure, then you have to provide braces, temporary braces, which is also known as shoring. So all those things need to be carefully planned beforehand. Also, once you fabricate the components in the factory, once the components are fabricated in the factory, they are to be properly stacked at the factory, and then sequentially they need to be transported to the site. And once you get them on the site, you have to first stack them on the ground. So for stacking them on the ground, you have to have a clear firm ground, and if possible it has to be at a place where there is no ingress of water, because being steel sections, they are prone to corrosion. So you need to have a clear platform, and they need to be stacked in a proper sequence, so that sequentially you can hoist them and take to the site and erect them sequentially. So it's all pre-engineered, decided beforehand, right from the steel plant where you are manufacturing these components, how you are stacking them. You have to even manufacture these components sequentially, then stack them there sequentially, then transport them sequentially, and while deloading, while doing unloading, you have to stack them sequentially and then erect them sequentially. It may look slightly cumbersome to you, but once you draw the sequence on the computer or on your paper, then things becomes very easy. It's like fixing fixing a bed. When you get a bed and you try to fix it yourself, you can do it looking at the drawing and looking at the sequence, because so in a similar fashion you can fix the entire building if you follow a particular sequence, and if that sequence is decided beforehand. Okay, this is also very important because a steel building, it is a steel building. So all these structural components made up of steel, they are to be handled and stored in such a manner so that surface abrasion and damage is avoided, because it's a steel, so abrasion may cause further damage, so that need to be avoided as far as possible. Also, there is a Indian standard available, which is IS 7969, which stipulates that in case of any damage during offloading, transportation and storage and erection, how these steel work can be restored so as to regain its original form. For that, there is the guidance, or there are guidelines given in 7969. All fastener and small fittings, when you are putting a fastener, so if your site is not clean, if your base plate or your bolt is not clean, you won't be able to fasten it well. So that need to be without dirt, under dry condition. Even wherever you are stacking these furnace, they should be packed, and when packing is removed and when brought to the site, they have to be properly cleaned. Okay, and then the anchor bolts are also very important. These anchor bolts need to be grouted with especially made concrete or non-stick ground or self-compacting concrete, because that grouting will hold your anchor bolt, which is of steel, with the concrete. So the grouting is done with a special grout. So now let's come to the column. So this is a layout of column, and again, let's see in this structural drawing, you will see that there are four different types of columns. So these four different types of columns will be made will be manufactured in the factory, and you can see these are the layouts. So here this column C1 will come, here the column C4 will come, and how this column is to be aligned and put is also given. This is like this. So longer portion is in this direction. For C4, the longer portion is in this direction. So their dimension, their web and flange dimensions, everything is given in the structure drawing, and what should be the layout is also given in this drawing. So based on this layout, you will start erecting those columns. Okay, then once you have erected beam and columns, then you have to put the slab, and slab being used here is a deck slab. So this is the section. So these are already erected beam. Over that beam you will lay the deck sheet, and this deck sheet is a profiled steel sheet which is of 0.9 mm thick. So with sufficient bearing on the beams, you will put this deck sheet, and over that deck sheet you will put a nominal reinforcement and put a concrete speed of 75 mm. So your slab comprises of a deck slab, and that deck slab comprises of a profile sheet of this kind with nominal reinforcement and a concrete screen. And again, the deck slab can be designed as per IS 456, and you only require a nominal reinforcement to take care of shrinkage and cracking. And this being a deck sheet, it provides, it also acts as a formwork. So these slabs can be, quickly made, and you can have the faster completion of your building. So once you have done the form, once you have erected the beams and columns, then you do the slab, and after doing the columns, the slab, your skeleton of building is ready. All you have to do is fix up the wall panels. Okay, so this is a typical floor plan which indicates you that when you are putting these deck sheets, how the slope, at a floor, slope of floor is very important. Okay, because so this slide shows you the framing plan. Wherever you are having a moment resting, moment connection, wherever you are having a shear connections, all these details are given in this typical floor framing plan, and it also gives you the slope. Okay, so accordingly you have to keep maintain that slope, and accordingly you have to align your deck sheets. Okay, so based on this first floor framing plan, you have to put those deck sheets and then lay the reinforcement and do the concreting, maintaining that slope. Okay, and similarly all those joints which depending upon the kind of joint you have to connect those joints either as a shear connection or as a shear movement, or as a movement connection. This drawing also gives you the detail about sunken portion. So what you see here, this is a sunken portion. So wherever you have sunken portion means the sunken portion is normally slightly below than your finished floor level. So sunken portion is being used to accommodate toilets. Okay, where you have Indian toilets, there you use a sunken portion. So like in this drawing, sunken portions are also shown. So when you lay these decking sheets, you have to lay these two decking sheets at a different level. This is slightly below and this is slightly above. So this structural drawing is also very important when you do the flooring work. Okay, and this already explained you. Once you have done what you have done, you have come up to the foundation level, then you have start erecting these columns, and once beam and columns are erected, you have to erect these light gauge steel frame. Okay, so what is the construction sequence, which is this is written here. First you have to transport these LGA7 steel sections as per the design. Then you have to erect this built up section over the RCC foundation using cranes and connections through nut and bolt and that base plate. You have to anchor, erect these the beam and columns. Having erected that beam and column, referring to that floor plan, you have to install decking sheets on each floor, and then lay the reinforcement cage, a nominal reinforcement cage, and do the concrete screeding. After doing the concrete screeding, you have to cure this slab, and now your building is ready to receive your light gauge steel frame. So these all light gauge steel frame panels which come from the site need to be put with the steel frames and foundations through connecting screws, and these panels are put side by side through self-tapping metal screws, and the wall position shall be marked on the floor and the wall structure by using a proper marking system. And after marking, you have to see the straightness, square, you have to see all joints whether they are at 90-degree square, and you have to see the levels through dumpy level. Nowadays magnetic split levels are also available, so through that you have to see all markings and all. And all these light gauge steel frame come with a bottom track, so you have to put that bottom track will help. And on that bottom track, it's again a C kind of section, and on that bottom track this panel will be inserted, and that will help you in aligning your wall panel straight, square, and in level. And once you do that, once you put this light gauge panel, then over that you need to put the precast concrete panel and then do the concreting. Before fixing the panels on the outer side of walls, you have to put all services as per your design. So electrical, plumbing services and other conduits need to be put in the cutouts of those precast panels, and then you have to put that panel. And once you have put all the services and those panels, you have to do the concreting of lightweight concrete, which is normally a self-compacting concrete, because self-compacting concrete we use, it is a special type of concrete which is also known as flowable concrete. You don't require any compaction of this concrete. So self-compacting concrete, and this also doesn't require curing because it is encased between two cement concrete panels. Okay, and once you have done the column, the building is ready, and now you can start your finishing work like you do in any conventional building. This is the finished thing. Those stages I show you. This is that cement concrete panel which we are fixing, and this is a typical. This is how your building will look like before putting the cement panel. So you can see here this blue thing. What you see is the steel I column, and this horizontal member. What you see is the beam, and this is your light gauge panel. Here some cross things are also put. These are called cross bracing. So if wind loads are higher, so sometimes you have to put cross bracings to for the wind load and even for earthquake loads. Okay, so this is how it will look like, and over this you will put this, and over this pre-cast the concrete panel you can do the putty, you can do the painting, or depending upon your project requirement you can do whatever you feel like. Okay, now let me talk about the finishing and the services. This is how services are being put. As I told you, that you fix the outer panel before, and before fixing the inner panel you have to fix all the services. So you can see this is a a connection box, then these are the electrical cables which are being put, and similarly you can put water things, so, the water pipelines, and you see other plumbing lines. Okay, so this is how finishing are being pushed, and if you see at the roof, this is how your electrical cables are being laid here. And this particular slide, if you see, these are your plumbing arrangements and your sewage lines are being put. And once you do all these things, you put a concrete panel, then you can fix the tiles. Again, tiles are fixed here, need to be fixed properly, and over those tiles you can fix your wash basin and all things. So services, again, services need to be carefully, need to be pre-planned, and they are to be inserted at the locations which are pre-planned. Okay, so this is how the finishing project will look like, and there are other finishing items as well in the project, which include pressed steel door frames with flush shutters, and in the wet areas we have PVC doors. Then all door window frames are of UPVC. Then vitrified tiles are being used, and anti-skid ceramic tiles are also being used, and in the common areas, instead of tiles, Kota stone is being specified. The other infrastructure facilities, social infrastructure, in addition to physical infrastructure, social infrastructure is also there. And some of the good provisions which are included in the project are street lighting, which are LED. And then the use of solar energy for street lighting. The project of this kind must have sewerage STP, which is a sewage treatment plant. So here also sewage treatment plant with recycling of water is included. Also rainwater harvesting and solid waste management, along with provisions for firefighting, are included in the project. These are few finished building by BMTPC. We are also promoting this technology through demonstration housing projects. So this is a project on left hand side. What you see is a project where this light gauge steel framing system without a steel frame was used in Telangana, and this is a very recently finished project in Panchkula, which was recently organized by our secretary. So these are the two buildings which we have done with the LGSF. That will be all for today, and being Technograhi, you have access to the gstcindia.gov.in site, and you can see the live status of all these projects, including this project at Agartala. On a daily basis, we are sharing the videos and photographs of the site. So if you want to know further, and if you want to see the status up to date, you can visit gstcindia.gov.in website, and there you will find a tab of live labs, and by clicking that live lab tab, you will get access to all photographs and videos. Also, when superstructure start coming up, I will be sharing those photographs with you, and giving you another lecture on superstructure. In order to inquire further, and if you have any doubts about the technology, or if you want to explore it further, you can contact us at Ministry of Housing and Urban Affairs. address. This is the email given. This is the ministry's email, and this is my email, ska@bmtbc.org. So you can write to me if you want to implement this technology. You can we can extend support to you. So with this, I finish this lecture. I hope you understood about the technology, and I hope you really enjoyed it. Thank you very much.